In section 3.2, we want to learn about some other identities like sum and difference identities. We want to see if there is a sum and there is a difference between the two angles, how we can define those as new identities. And the first formula that we see in this slide is the cosine of the difference of two angles. And sometimes when we are finding the trigonometric function of some angles, we see that it's much easier that if we have angles in terms of two other angles. For example, I know that what's the cosine and what's the cosine of 30 degree and what's the cosine of 45 degree, but I have no idea what's the cosine of 15 degree. But I know that the 15 degree, it's 45 minus 30. And this formula, the cosine of difference of two angles, helps me to find the cosine of 15 degree as a difference of two other angles like 45 and 30. And based on the formula, if we have the cosine of the difference, or even if it's add between the two angles, we need to multiply the cosine of the two angles, the cosine of the first angle, which is alpha, the cosine of the second angle, which is beta, and then multiply the sine of those angles. And then if there is a minus here, if there is a difference between angles, we add them. But if it's addition, if we have cosine of alpha plus beta, we need to subtract these two. Let's see how this formula can help us. For example, we know that the cosine of 30 degrees is root 3 over 2. But we can also find this number, find this value by using the cosine of 90 minus 60 degree, because 90 minus 60 is also 30 degree. So if I use the difference formula for 90 minus 60, it should give me the same value at the end. And you'll see that the cosine of 90 minus 60 is the cosine of 90 times cosine of 60, sine of 90 times sine of 60 degree, and then add them together. Cosine of 90 is 0, 0 times 1/2, which is cosine of 60, it's 0. Sine of 90 degrees 1, sine of 60 degrees root 3 over 2, and 1 times root 3 over 2 is just root 3 over 2. And you see that the cosine of 30 degree, which is 90 minus 60, that's exactly the same as what we'll remember from the table value in last chapter. Next example. They are asking us to find the value of this expression. Okay. When I look at this expression, so I'm supposed to know what's the cosine of 70 degree, find the answer. Yes, I can use the calculator and find the cosine of 70, cosine of 40, because we don't have 70 degree or 40 degree in the table value. But we can use calculator, find these values, put them on the expression, replace them, and then multiply, add them together. But you know that those numbers always give you decimal number. And that makes everything more complicated. But when I look at this formula, it reminds me of the cosine of difference. So it means that I can use that formula as well. I have a cosine of 70 times cosine of 40. I have sine of 70 times sine of 40. And there is a addition between them, which means that's the cosine of difference between 70 and 40. So instead of these whole expression, I can just have the cosine of 70 degree minus 40 degree. And I know that the 70 minus 40 is just 30 degree. And the cosine of 30 degree, it's on my table value. I know the answer, and the answer is root 3 over 2. And that's it. We don't even need the calculator. We don't even need to put all those decimals, multiply them, add them together, and we are done just by using the formula. We want to use the cosine of difference this time to verify the identity. So we have an identity here. We want to verify this identity, which means that we want to show that the two sides are equal to each other. And I see that part of this identity is the cosine of alpha minus beta. Okay, so to verify the identities, we always start from one side, which is the most complicated side. In this case, since I have a cosine of alpha minus beta, I prefer to start from the left side. Even if you think the right side maybe is more complicated because it has a tangent, but I prefer to start from left side because on the left side I see cosine of alpha minus beta and I know a formula to replace for that. And I want to see how it works. So we start from the left side. So for the left side, instead of cosine of alpha minus beta, we replace the formula. We replace cosine of alpha times cosine of beta plus sine of alpha times sine of beta, and we keep the denominator the same. Now when I look at this whole fraction, I see that I have two terms on the numerator and one single term on the denominator. Every time we just have one single term on the denominator, when the numerator has more terms, we can write them as a separate fraction. And we can put this single denominator under each of the terms of the numerator. And if we separate the fraction, we get this. And when you separate the fraction, you can see that these two cancel each other. And from the first fraction, we only have one. Okay, that's good. And the second fraction, we have sine on top and the cosine on the denominator of the same angles, which means the sine of alpha divided by cosine of alpha, which is tangent of alpha. I know that as a fundamental identity. Sine of beta times cosine beta, again, is a tangent. So I have 1 plus tangent alpha times tangent beta, and that's exactly my right side. And now this identity is verified. In this slide, we can see all of the sum and difference formula for sine and cosine. We have 2 for sine, cosine, 2 for sine, 1 for sum, 1 for difference. And the same for sine. 2 for cosine, 2 for sine. So for cosine formula, you need to multiply the cosine of the two angles first, the sine of two angles, and then add or subtract them. And if it's addition, if you have a sum, you need to put minus between those two terms. But if it's minus, you put sum. But when you have the sign of sum or difference between angles, you need to multiply the sine of the first angle by the cosine of the second angle. And then we switch. We multiply the cosine of the first angle by the sine of the second angle. And the sign between them is stay the same. If it's plus, we put plus. If it's minus, we put minus. So for cosine, we multiply the cosines first and then sines. But for sine, we multiply the sine of one angle by the cosine of the other angle. And we switch by multiplying cosine of the first angle, sine of the second angle, and then add or subtract them too. Let's look at next example. In this example, it says find the exact value of the sine of 5 pi over 12. Okay, this time the question tells me that the 5 pi over 12 is pi over 6 plus pi over 4, but you may not have this option when you're working on the homework. They just ask you, what's the exact value of 5 pi over 12? If it's hard for you to know what is the angle, you can just change it to degree instead of radian. And if you change 5 pi over 12 to degree, you get 75 degree. And we have no idea what's the sine of 75 degree. But I know that the 75 degree, it can be written as a sum of 30 plus 45. So that's why here it tells you that the 5 pi over 12 is pi over 6 plus pi over 4, because pi over 6 is 30 degree, pi over 4 is 45 degree, and 30 plus 45, that exactly gives you 75 degree. And if I know one angle can be written as two other angles, which those angles are known for us, we can easily use the sum formula. And instead of writing the sine of 5 pi over 12, I can write sine of pi over 6 plus pi over 4. And use the formula for the sum of the two angles, because for sum we have the sine of first angle times the cosine of the second angle, plus cosine of the first angle times the sine of the second angle. And now, since I know the sine of 30 degree, I can replace numbers. Since I know the cosine of 45 degree, so just replace numbers. What's the sine of 30 degree is 1/2. The cosine of 45 is root 2 over 2. The cosine of pi over 6 is root 3 over 2. And the sine of 45 degree or pi over 4 is root 2 over 2. And if you replace numbers, and based on the order operation, multiply the fraction first, multiply these two fractions, multiply these two fractions, and then add them together. And if I multiply the first fraction, 1 times root 2 is just root 2, and 2 times 2 is 4, because we always multiply the numerators and then multiply the denominators. For these two, multiply the numerators. Root 3 times root 2 is root 6, because both of them are under the radical. We can multiply them. And 2 times 2, which is 4. And since both of them have the same denominator, we can rewrite them as a common denominator with root 2 plus root 6 over 4. And now I have an answer for the sine of 5 pi over 12, even if it's not on the table. So the goal of just learning all these formulas is just finding more and more trig of the other angles. I know 30 degree, 45 degree, 60 degree are known angles. We can use them always. But even if they ask us to find the sine or cosine or other trigonometric function of other angles, which are not known for us, we can use different formulas, fundamental identities, the sum and difference formulas, and to find those angles as well, the sine and or cosine of those angles. Next example. It says find the exact value. We have the sine of beta, which is 1/2, and we know that the beta is in quadrant 1, and we want to find the cosine of beta. Okay, so let's see what we can do. We may have different options. For this problem, we can use right triangle properties, or we can use a trig identity. If you want to use a trig identity, you can use the Pythagorean identity, which is sine squared plus cosine squared is always equal to 1. If it's beta, we just put beta. And we know that the cosine of cosine squared is always 1 minus sine squared based on this formula. And if I replace the sine by 1/2, 1/2 squared is 1/4, 1 minus 1/4 is 3/4. And since the cosine square is 3/4, if I take the square root from the both sides, I get root 3 over 2, because 3 doesn't have a root. 3 is not a perfect square, stay under the radical, but 4 is a perfect square, we can bring it out as a 2. And we also know that whenever we take the square root from the both sides, we need to have a plus or minus, but since our angle is in quadrant 1, and we know that the cosine in quadrant 1 is positive, we keep the positive only. So that's my final answer. That's one method to solve this problem. We can also use the right triangle property, and based on the right triangle property, we know that the sine of any angle is y over r, because if you have an angle in the first quadrant, the sine is always opposite over hypotenuse. So opposite is 1, hypotenuse is 2, and we want to find the cosine, and the cosine is adjacent over hypotenuse, which means we need to find this side first. And this side is x. And how do we find that? By using the Pythagorean theorem. And by using the Pythagorean theorem, we find that the x must be root 3. And again, since x is in the first quadrant and we know that x is positive, we keep it positive after taking the root. And now we can find the cosine, and the cosine is x over r, or the adjacent over hypotenuse, which is root 3 over 2. So you can use either of these methods. You don't need to have both, just one of them. You can use a trig identity, or you can use a right triangle property. Now, in the next example, we have a sine of an angle alpha, which is 3 over 5, and angle is in quadrant 1. We have a sine of another angle beta, which is 5 over 13, and that angle is in quadrant 2. And they are asking us to find the sine of alpha plus beta. Okay. Or find the cosine of alpha minus beta. So let's see what we can do. First of all, we need to write the formula for sine of alpha plus beta. Anytime you see two angles are adding or subtracting inside the parenthesis, try to use the correct formula. The sine of alpha plus beta is sine of alpha times the cosine of beta, the sine of the first angle, times the cosine of the second angle, plus now cosine of the first angle times the sine of second angle. Now we need to check which one of these functions are given to us and which one we need to find them first. I have the sine of alpha, which is 3 over 5, but I don't know the cosine of alpha. So I need to find the cosine of alpha first. I know the sine of beta, but I don't know the cosine of beta. So I need to find the cosine of alpha and cosine of beta by having their sign first as a first step. I can use trig identity like we did in the last example, or we can use a right triangle property, which I think the right triangle property may be easier for you. So let's do that. We know that the sine of alpha is 3 over 5. And I know that sine is always opposite over hypotenuse. And the alpha is in quadrant 1. If I have an angle in quadrant 1, like this one, we can create a right triangle here. And if that's my angle alpha, the opposite is 3, hypotenuse is 5. And to find the cosine, we need to find this side first. Using the Pythagorean theorem, so 5 squared, which is equal to 3 squared plus x squared. Solve this one. We get x equal, so x squared is 5 squared, which is 25, minus 3 squared, which is 9. 25 minus 9 is 16. And if I take the square root from both sides, x must be equal to 4. And since x is on the first quadrant, it's positive. Now I can find the cosine of alpha, which is adjacent over hypotenuse, and that's x over r, which is 4 over 5. Okay. I'm done with the first cosine. Now I need to find the cosine of beta as well. We do exactly the same. We know that the sine of beta is 5 over 13, but this time beta is in quadrant 2. So if it's in quadrant 2, we have an angle, something like that. That's my angle. And opposite is 5, hypotenuse is 13. We need to find x. So using the Pythagorean theorem, so x squared is equal to 13 squared, which is 169, minus 5 squared, which is 25, and the answer is 144. So if I take the square root, x must be equal to a square root of 144, which is 12. But this time, since x is in the second quadrant and the x on the other side is negative, we need to keep it negative. Now I can find the cosine of beta, which is adjacent over hypotenuse, and it's negative 12 over 13. Now I have everything ready, and I can replace the numbers into the formula. So what's the sine of alpha? Is 3 over 5 times cosine of beta, which is negative 12 over 13, plus cosine of alpha, which is 4 over 5, and the sine of beta, which is 5 over 13. So multiply the first two fractions, multiply the second two fractions, and then add them together. If I multiply the top by top and the bottom by bottom, we get negative 36 over 13 times 5 is 65. Second two fractions, 4 times 5 is 20 over 65 again. Since the denominators are the same, we can add or subtract the tops, and there negative 36 plus 12 plus 20 is negative 16. And that's the final answer. Part B is asking you to find the cosine of alpha minus beta. So what's the formula for the cosine of alpha minus beta? Since I have a cosine, I need to multiply the cosines first. We say cosine of alpha times cosine of beta. Then we multiply sine of alpha times sine of beta. But if it's minus, we add this. I need the cosine of alpha, which I have it. I need the cosine of beta. Again, I have that information. Since I have all of the sine and cosines, it's easy just to replace the number. But if we need something, we needed other function, we had to find them first. So negative 12 over 13 plus sine of alpha, which is 3 over 5, times sine of beta, which is 5 over 13. 65 is negative 48. 15 over 65. Negative 48 plus 15, which is negative 33. And that's the final answer. Next example is asking you to find the exact value of this expression. What's the cosine of 50? I need to know what's the cosine of 50 multiplied by cosine of 20, and sine of 50 multiplied by sine of 20. And I don't know, they don't have any information about 20 degree or 50 degree. But something that is familiar for me is that the whole expression gives me a new formula. When the cosines multiply together, sines multiply together, and there is an addition, it tells me that is the formula for the cosine of difference angles. The difference between 20 and 50, which is 30 degree. So that means this whole expression is equal to the cosine of 30 degree. And the cosine of 30 degree is root 3 over 2. And I'm done. We have formulas for the sum and difference between angles for tangent as well. If I have a tangent of alpha plus beta, so we will have a fraction for the numerator. We need to add tangent of each of those angles, the tangent of alpha plus tangent of beta. And for the denominator, we need to multiply tangent of alpha and tangent of beta and then subtract it from 1. So it's 1 minus tangent of alpha times tangent of beta. And something that it may help you to remember, whenever you have addition, so numerators is addition, but the denominator is subtraction. So if it's subtraction, the numerator should be the same, which is negative against subtraction, but the denominator is always opposite, which is positive or addition. Okay. So next example says verify this identity. We have tangent of x plus pi, which is equal to tangent of x. How we can verify this identity? By starting from one side, which I always start from the left side. And the left side is the tangent of x plus pi. Okay, what's the tangent of x plus pi? If I don't want to look at the unit circle, I know that I have a tangent of sum of two angles. That's my first angle and my second angle. And I can use the sum of the formula for the tangent of two angles, this formula. Okay, I'm going to use this formula for the tangent of x plus pi, which is tangent of x plus tangent of pi, 1 minus tangent of x times tangent of pi. I don't know what's the tangent of x is because I don't know what's the x. It's a variable, but I know the tangent of pi. Tangent of pi, it's the sine of pi over cosine of pi. And if you remember from the unit circle, the pi is over here. And to find the tangent of pi, you need to divide sine of pi by cosine of pi. But since the cosine of pi is -1, but the sine of pi, since this point it's on the x-axis, the sine is always 0. And 0 over any number is always 0. So the tangent of pi is 0. This one is also 0. So from numerator, I only have tangent of x. And for the denominator, I have 0 times tangent of x, which is 0 again. And 1 minus 0 is just 1. So I have tangent of x over 1, which is exactly tangent of x. And now, since we started from the left side and we got the right side, that means this identity is verified. For the next example, we have a sine of alpha, and it tells us that the alpha is an angle between 0 and pi over 2, which means it's in the quadrant 1. The cosine of beta is also given to us, which is -5 over 13. And the beta is an angle between pi and 3 pi over 2, which means the beta is an angle in quadrant 3. Now it asks you to find the tangent of alpha plus beta. Okay, to find the tangent of alpha plus beta, you need to write the formula first. What's the tangent of alpha plus beta formula? That's the tangent of alpha plus tangent of beta, 1 minus tangent of alpha, tangent of beta. Okay. If I want to find the tangent of alpha plus beta, I need to have the tangent of alpha and tangent of beta, but we don't have them. For alpha, I only have the sine. For beta, I only have the cosine. So I have to use them with the properties of a right triangle to find the tangent of them first. So I know that the sine of alpha is 3 over 5. And I know that the sine is always opposite over hypotenuse. So if I have an angle in the first quadrant, that's alpha. The opposite is 3 and the hypotenuse is 5. But if you want to find the tangent, for tangent you need opposite over adjacent. So you need to find the adjacent first. That means this side. We use the Pythagorean theorem again to find the x, and we did it on the previous slide, and the x should be equal to 4. So now you can, so I'm just writing the Pythagorean theorem here to remind you that you need to complete this part and find the x from this formula. After finding the x, you know the opposite is 3, adjacent is 4, and since the angle is in quadrant 1, the tangent is positive. That means x and y, both of them are positive. So the tangent of alpha is 3 over 4. Now I need to find the tangent of beta. For beta, I only have the cosine. I know that the cosine of beta is -5 5/13. And the cosine is always adjacent over hypotenuse. So we have an angle in quadrant 3, something like this. And if we create a right triangle in quadrant 3, and that's your angle, the adjacent is -5, hypotenuse is 13. But for tangent, you need opposite over adjacent, which means you need to find this side first. If I call it y, I need to find the y by using the Pythagorean theorem. And based on the Pythagorean theorem, I know that 13 squared must be equal to -5 squared plus y squared. And if you solve this one, you get y squared, which is equal to 144. If you take the square root, y must be equal to 12. But the question is it positive 12 or -12? Since the angle is in quadrant 3, and in quadrant 3, both of the x and y are negative, so the y also must be -12. Now you can find the tangent, which is opposite -12 over adjacent -5, and you can cancel negative by negative, so the tangent of beta is 12/5. Now everything is ready, just plug it into the formula. Tangent of alpha is 3/4 plus tangent of beta, which is 12/5, 1 minus tangent of alpha, which is 3/4, times tangent of beta, which is 12/5. So please don't forget the order operation. Based on order operation, we need to find the multiplication first before any add or subtract. So you need to multiply these two first from the denominator. And if you multiply them, 3 times 12 is 36, 4 times 5 is 20. Now you need to subtract that number from 1 by finding the common denominator. You can also simplify 36/20. If you divide both by 4, you get 9/5. And now if I find the common denominator, which is 5, 1 times 5 is 5. 5 minus 9 is -4/5. That's my whole denominator. So I keep this on the denominator. And for the numerator, I only need to add two fractions by finding the common denominator. And the common denominator between 4 and 5 again is 20. 4 must be multiplied by 5, so 3 times 5 is 15. 5 must be multiplied by 4, and 12 times 4 is 48. And 15 plus 48 is 63/20. That's the numerator. So I have a fraction between two fractions, so I prefer to rewrite them in another form of division. So I have 63/20 divided by -4/5. And for dividing two fractions, I need to do the keep flip change. Keep the first fraction the same, flip the second fraction, and then change it to multiplication. If there is any numbers, you can simplify first. If there's nothing to cancel anymore, just multiply the top by top and the bottom by bottom. So the answer is -63/16. Now let's see how we can use these formulas to solve an application problem. In this example, it says for a climbing wall, a guide wire R is attached 47 feet high on a vertical pole. That's this one. Added support is provided by another guide wire S, which is attached 40 feet above the ground. Okay, so wire R is attached on the 47 feet. and wire S attached 40 feet above the ground. Okay, if the wires are attached to the ground 50 feet from the pole, find the angle alpha between the wires. We want to find this angle. Okay. Right now, when you look at this picture, or if there is not any picture, remember that for solving all of the application problem, create a picture for yourself and makes it 100 times easier for you to understand. And after creating picture, looking at this picture, I see right triangles. So you can find right triangles, these right triangles here. And we have two right triangles actually. I have one right triangle. This side is 50 feet. This side is 47. And that's my R. And the angle here is called beta, is this one. And I have another right triangle for wire S. This side is still 50. This side is 40. And we don't know the angle, this angle. We don't know this angle. We can just give it a name. For example, theta. Theta. Just let's give it a name for this angle. And we want to find angle alpha. And as you see in the picture, the angle alpha is the difference between the other two angles, beta and theta. So it means if you want to find the tangent of alpha, so let's start with, so always, whenever in all of the application problems, when they ask you to find an angles, you need to find one of the trigonometric function of that angle first, like the sine of angle or the cosine of that angle or the tangent of that angle. And why I mention tangent, because when I look at both of my right triangles, I see that for both of the triangles, I have the opposite side and the adjacent side. Opposite over adjacent is the tangent. So it's easier that I find tangent of these angles. And so that's why to find angle alpha, I start finding the tangent of alpha first. So the tangent of alpha, which is actually the tangent of beta minus theta. Because if you look at this picture, angle alpha, it's a difference between the whole beta and theta. Okay? Now, when I have difference between two angles, I can use a difference formula, which is tangent of beta minus tangent of theta, 1 minus tangent of beta times tangent of theta. Sorry if I'm pronouncing the two angles the same. One of them is beta, and the other one is theta. Okay. Now by writing this formula, I can find the answer faster because I can easily find the tangent of beta from this triangle. I can find the tangent of theta from this triangle and just plug it into the formula. And to find the tangent of beta, I only need the opposite over adjacent, which is 47 over 50. So the tangent of beta is coming from the first right triangle, and that's opposite over adjacent. And the tangent of theta can be found from the second triangle, and it still is the opposite over adjacent, which is 40 over 50. And by having them, just plug it into the formula and find answers. Okay. So in the numerator, we need to subtract the fraction, but since the denominators are the same, it's easy. Just subtract the tops. 47 minus 40 is just 7 over 50. For the denominator, I need to multiply these two first, which gives me, there's nothing to actually simplify except the zeros. And the answer is 1,880 over oh, sorry, 188, because I canceled the zero, and 50 times 5, which is 250. And then I need to find this common denominator for these two fractions, which gives me 250 minus 188, and the answer is, see, 250 minus 188, and the answer is 62. And I have to divide these two fractions by keep, flip, change. So keep the first fraction, flip the second fraction. I don't have a space. And then multiply them together. Just write it down. I will write it over here. And we simplify, yes, we can simplify 50 by 250. And I get 7 times 5, which is 35 over 62. And that's the final answer. But that's not the final answer, actually. That's a tangent of the angle that I'm looking for. Okay? And now, to find the alpha, I need to use my calculator. And to use the calculator for finding the angle, and which, and let me just erase this. And the function that I'm going to use in my calculator are the tangent inverses. So we learn about inverse function. So if you want to find the alpha, you need to find the tangent inverse of that number, which is 35 over 62. And if you type this one in your calculator, you can find angle alpha. It should be about 4.57 degree angle. Next example, if you want to find the exact value of this one way is just finding the tangent of 10 degree, tangent of 35 degree, and then plug into the formula, replace the numbers, and then add or subtract the numbers. Or by looking at the whole expression, you remember that this should be equal to the tangent of sum of two angles. Because in the numerator, I have a tangent of alpha plus tangent of beta, 1 minus tangent of alpha times tangent of beta, which should be equal to the tangent of alpha plus beta, and that's 10 plus 35. And 10 plus 35 is 45 degree, and I know the tangent of 45 from the table value, which is equal to 1. So these whole fraction should be equal to 1. So instead of finding the tangent of 10 or tangent of 35 using the calculators and plugging those decimal numbers, adding them, multiplying them, just use the formula for the sum of two angles.